Welcome to Birkbeck Online. We will be discussing renewable transport, the synthesis of renewable gases and liquids for the energy and transport sectors. This is part of the module Energy and Climate Change, and my name is Jo. First of all, we're going to consider cars. In the future, cars will look very different to the way cars look now. One of the reasons why cars must change is because of urban air pollution. In cities, cars concentrate in the centres, creating pockets and webs of air pollution, which significantly affect people's health. A range of measures have been put in place by cities and countries in order to suppress air pollution, particularly in urban environments. The time horizon for change is continually being redrawn closer and closer to today. This diagram from the Faraday Institution projects that there will be a rapid turnover in the car fleet based on vehicle sales, so that by 2040, electric vehicles will be the overwhelming majority of new car sales. In reports on transport, there is a range of three-letter acronyms. The trend will be towards more electric vehicles, but also towards smaller vehicles. The projection by the Department for Transport in the UK is that more than 90% of car mileage by 2050 will be done in electric vehicles. This projection, however, has some interesting outcomes in that traffic congestion could increase significantly, as could traffic, and carbon dioxide emissions in total may not fall to the desired level. Part of the reason for this is that battery electric vehicles may well turn out to be cheaper to run and cheaper to buy, and so more people could own cars, and so this will contribute to higher traffic. The transition to battery electric vehicles will not remove all sources of air pollution, as some of the most dangerous air pollution is caused by friction, for example, road abrasion, tyre wear and brake wear. 2 wheels will be better than 4 in curbing air pollution, so the rise of two-wheeler vehicles is expected to be great. This is the summary by the International Energy Agency from their Global EV Outlook 2020, that is, the outlook for electric vehicles. It shows 2 possible scenarios for 2030, the steps, stated policies, and the SDS, the Sustainable Development Scenario. The 2 IEA scenarios show a great difference in the amount of electric vehicles that will be held in the global stock or fleet. Here is another projection from Bloomberg New Energy Finance on the outlook for electric vehicles. This chart is from the 2018 version, This is modelling from Deloitte from 2019. And you can see that there is some lack of confidence about the near-term progress. This is the same modelling team in 2020, and you can see that there has been a significant dip in vehicle sales. The 2020 update by Bloomberg for their projection also shows a significant dip in global annual passenger vehicle sales. Their projection for the crossover between electric vehicles and internal combustion vehicles is now roughly 2037. It's not just the number of sales of new vehicles that is important. It is also the number of kilometres travelled by each kind of car. This is the Bloomberg projection from the New Energy Outlook in 2020. And you can see that internal combustion engine vehicles, those that burn diesel or petrol gasoline, still figure significantly in the number of kilometres travelled in 2050. The headline numbers from the Bloomberg Electric Vehicle Outlook 2020 make the point even more clearly. Of the global vehicle fleet in 2020, there were about 8.5 million electric vehicles in a total global fleet of 1.2 billion. In 2030, Bloomberg expects there to be around 116 million electric vehicles and a total number of vehicles in the global fleet to be at 1.4 billion. Gandhi and Polchev in Transportation Research in 2020 took a look at 3 different scenarios and showed similar numbers for the global LDV stock, that is, light duty vehicle, in other words, passenger cars. Their projection for electric vehicles in the global stock was also similar. McKinsey and Company, presenting to the IEA Symposium on Energy Outlook 2020, has a slightly less optimistic projection, or optimistic. So the total number of polluting cars is higher, but the total number of electric vehicles is also higher. This is the IEA's mobility model from a projection done in March 2017, comparing numbers for 3 different scenarios: B2DS, below 2 degrees scenario, 2DS, 2 degrees scenario, and RTS, the reference scenario. So, a range of projections. One conclusion is that there will still be a considerable number of internal combustion engine vehicles running on diesel and petrol gasoline still on the roads in 2040, 2050. Part of the reason will be due to large increases in passenger vehicles in countries such as China. Higher electric vehicle sales will not result in dramatic declines in the number of diesel and petrol gasoline cars on the roads. One of the reasons is that there is a large second-hand and third-hand market in vehicles. Another reason is that people may decide to keep their ICE cars for longer. if there is an increase in the lifetime of the average vehicle, it will limit the chances of reducing emissions to a safe level in an appropriate time. So, there is a wide range of technology in powertrains and engines, and it's worth noting some of these. Here is a simplified schema for each type of vehicle. Here is another schema for the main categories of vehicle. And here is another diagram talking about the categories of vehicle. As there will continue to be large numbers of ICE vehicles on the road, it is very important to address air pollution directly, and there are many standards on catalytic conversion and emissions cleaning in cars. The transition to electric vehicles could have impacts that are wider than the transport sector. Part of the reason is that electric vehicle charging may have peaks in the profile. There are many studies being done to try to understand the potential for stress in the electricity system due to fast charging. Some electric vehicle refueling stations will have batteries on site so that fast charging does not disturb local grids. Other refueling stations may have a gas supply and their own generators to generate electricity on site. This may be easy to solve. But what can we do about the ICE vehicles? Can we reduce air pollution as well as cutting carbon dioxide emissions? This slide from Shell suggests that it will be possible to provide zero carbon fuels and to make sure that vehicles are zero emissions.